and at the end the stream classification using Apache Spark. So text classification is, the goal of the text classification is, given a news article, we have to find out which topic or which section of the newspaper it belongs. For example, this can be an example news article, and possible labels might be science, business, sports, politics and others. So we can think of it as a pipeline where you load the data first, then you do the feature extraction part, you train your model, and you will evaluate your model using the specified evaluation metric. It can be either accuracy, precision, recall, or information. So now we will focus on extracting the features from the text using Apache Spark, especially Spark ML libraries. So mllib.features has a collection of methods that can help you to achieve the pre-processing task, and we will focus on first on tokenizer. So tokenizer is a process where you break down the big chunk of text into words. So in this example, we will be using a tokenizer from PySpark's ML feature library, where we will create a data frame first. And as you can see, this data frame has two entries. One starts with a 0 here, and another starts with a 1. 0 and 1 are the IDs, and the text is for 0 is here and for 1 is here. So there are basically two documents, and at the end you specify the structure or the column names, that the first column is an ID and the second column is a sentence. That's how you create the Spark data frame from like regular, it's a kind of basic initialization. At the tokenizer, when you create the tokenizer, you specify the input column, which is in this case sentence, because sentence indicates the second column. So 0 is the first column, this text is the second column. So you specify the input column, and you also specify the output column, which will be words. So this is a part of a pipeline. So later processing task will look for the output columns from this task. So, and you call tokenizer.transform, you hand over the sentence data frame, and it will show you the output after it does the processing job. Another pre-processing task is a stop word remover. So as you have seen, that stop words are the words that have very little impact on the text classification. So we remove them to make our processing job a little bit easier. So this is our example data frame we have, where ID you have raw data words, and after the step you will get the filtered words. So as you can see, there is no for in this section, in this part of the table, because a for is listed as a stop word, so it has been removed. So for that we will be using PySpark ML.feature stop words remover. Again you create the data frame, but this time you create it with index and raw words, I mean the words from the sentence. Again it is a index and words from a sentence. Another one, index and word from a sentence. You specify the columns as ID and raw data. Again here you will get the stop words remover class, where the input column will be the raw. So this will be the input, and the output column will be filtered. So in the previous slide we have already seen how the filtered output will look like if you give them this raw data. Again you call the transform method from the remover stopper remover instance and hand over the sentence data, and it will show you how the data looks like after a processing job. It will be like a table with columns. Here at the end we are doing the text pre-processing and generating n-grams basically, where we will be using the n-gram class from the PySpark's ML feature again, and this set of words are identified as words, and again the 0 and 1 are ID. So now we will create an n-gram instance, and we are saying that we will be using n equals to 2. So basically we are using bigram. We are generating bigrams. We expect the input column name should be words as it is given here, and the output columns will be n-grams. So you have to always consider that if you are handing over a particular data structure, then your input column should match the particular portion of the data you are considering to process. And you create n-gram.transform, you hand over the word data frame, it will give you the n-gram data frame. Now within the data frame you can type the select operation and specify the column name you are interested in. So it will show you that particular column. As you can see, a data frame is usually a kind of table where you have multiple columns. You can always specify which column you want to see, and it will show you that particular column. So for feature extraction, we will be using also the TF-IDF feature extraction part, and we have the hashing term frequency and the count vectorizer. Both can be used as a term frequency section, and there is an IDF class that will give you the inverse document frequency for a particular word. If you see this code, we are creating the data frame first. Again, the name of the columns are label and the words. We are creating the hashing term frequency where the input column is words matching with this one, and the output column is raw features, and num features is 20. So it will do like this. I mean, if you have a corpus with 100 of the words, it will take the most frequent 20 of them. So we are limiting the number of features here. We don't want the entire 100 entire number of words. We only want the top 20. Then the feature data we call the hashing term frequency instance and transform the word data frame. Then as you have seen, the output column here is the raw features, and the IDF input column becomes the raw features. So after calculating the term frequency, you are now focusing on the inverse document frequency here. So your input column raw features, which is the previous output column, and the output columns becomes features. So always, I mean, this is a kind of pipeline example that you are doing first the hashing term frequency first, then you are doing the inverse document frequency portion. You have to always consider the name of the columns that you are interested in. It should match, like the output column from the previous pipeline should be the input column of the next stage. And you call the idf.fit and feature data to create the IDF model. After that, you call the rescale data IDF model, and again you call the transform method. So always transform method actually transform the data into the desired output form you want. Now reselect data is again a data frame which has a label and the features. So, where you can see the labels, there is the label, and the features comes out to be after the IDF step. So, there is another concept that you start with a data frame, you keep adding columns to it. So, you started with the label and the words column, then you added the raw features column, then you added the features column. So, starting with this data frame, after this step you have basically 4 columns: label, words, raw features and features. From there you are basically selecting 2 of the columns, which is label and the features. It will show you the features, that is the inverse document frequency, after the inverse document frequency, and the label. So, there is another feature extraction method using word to vec. This is like, as professor explained, it actually converts a word into a vector, where you can find the semantic meaning between the words as and can be described with algebraic manner. Again, we are using the data frame, specifying the words in the data frame. This time we have only one column, which is text. We instantiate a word to vec object. We expect the vector size for each word to be 3, and the input column will be the text. So, text gets as an input to this step. The output column will be named as result, and you should see that there is a word to vec dot fit method, and after that you transform. Now, for each row it will be organized as a text and a vector. So, you will have a word and its corresponding vector. You can see with the print statement, it will give you the output of the representation in word to vec format. Now, we will focus on how to do text classification using Apache Spark. We are in the kind of after extract feature, we will focus on the training models part, where we will train model using different machine learning classifiers already specified using Apache Spark ML library. So, these are some methods that has been already presented in the course before, and also are available through MLlib package. So, for a text classification instance, you will always have to have 2 columns in your data frame. One is label, one is features. So, with the default setting, if you hand over a data frame to a classifier, it will expect that you have a label column where it will find the actual label, and it also have the feature column that is representative for each of the words, each of the articles in the collection. So, there is an example actually. So, this is your data frame, and 1.0 is the label, and this is the vector representation of some document maybe. This is another format where you can so this is basically converting the previous output, where you have the label, feature, you can specify it in a single vector. Labeled point, it can convert it to the appropriate format for the classifier to work on, because you have specified one vector where the first one is the label for your particular document. After this label point formatting, it will be like this. You have label outside of the rest of the features. Now, we will be focusing basically with naive Bayes. We can how to do the classification and different stages of it. So, you can see, right? Yeah. So, again we are thinking of within the Spark how we can use the naive Bayes. So, we have to create the Spark context first to run a program inside a Spark. We will specify which data file we want to focus on. This is our training plus test data basically. So, we are loading the data as an RDD file with sc.text file. It will read the content from the text and it will give you the data as an RDD. So, we do split the data into training and the test data, so that we can see our model trained on the training part and we do our evaluation on the test data. Then we create a naive Bayes where the model type will be multinomial. So, we are expecting that the class there will be several classes, not the binary classes. There will be more than 2 classes in the data. Then we train the model with nb.fit method and we pass the train data portion of the data set and we do the predictions on the test data in the next line with model.transform. This is a multi-class classifier, so we will use an evaluator with multi-class classification evaluator, where the label column, it requires the label column, the prediction column and the type of accuracy, type of metric we are interested in. So, always classifier gives you, you are handing over a data to classifier. Classifier gives you the same data with the prediction column added to it. Yes, please.
Yeah, so here, does the naive Bayes classifier pick up the number of classes from the data set?
Yes.
Okay.
So, when you do the predictions, it has labels and the prediction columns and we specify the metric name accuracy. So, you are interested in to see the accuracy of the classifier. Then you hand over the predictions you got from the model transform method to the evaluator and it can give you the accuracy. Similarly, you can run the decision tree classifier. Again, you load the data from the data/guardian.txt as an RDD file. Then you split the data into training and test and create your model with decision tree.train classifier. You hand over the train data. In this case, you know that you have binary, it is a binary classification. This is just example programs. And again, you do the predictions with model.transform test data, and you evaluate your multi-class classification with classifier, multi-class classification evaluator. You can also use the SVM one, where again you do the training test split and you run the linear SVC from the Spark MLlib classification package and you feed the training data and later part. I mean the rest of the part follows as the previous examples. So, now we will focus on the text classification evaluation by the Apache Spark. What Apache Spark provides to do the classification evaluation, as we have already seen actually. So, So, in this part we will be focusing on the cross validator that has been provided by Apache Spark to see how we can run the cross validation on the dataset given. So, basically it begins splitting the dataset into set of folds. So, it at each of the time, like say you have 5 folds. So, at each of the time it will select different instances for testing dataset and train on the rest of the data. Also, you can specify the param maps where you can specify model, the classifier specific params, like how we want to do the regularization. There might be regularization parameter set to be 0.1. You also want to see how it looks like for 0.01. You can put them all together in param maps, and cross validator will do the rest of the job. It will run through each of the parameter value for the 5 folds step, and it will give you the result back. Here is an example. It's kind of a complete example how you do from the beginning to the end with all the pre-processing task kind of thing. So, you import the necessary libraries you will be required for the process, and you start with pre-processing task where you do the tokenization, then you do the calculate the term frequency, and you will be using logistic regression for this example, and you create the pipeline. So, in the pipeline you will have 3 stages. You will do the tokenization first, then you want to do the calculate the term frequency, and after that you will apply the logistic regression function. So, there are 3 specific. This is the tokenizer, this is the hashing term frequency, and this is the LR. Both are defined above, and you will be seeing that there are relations between the columns. And for example, in this input column it has been written like tokenizer dot get output column, which will be the words basically. So, it's a as you have told that it the cross validator also can have the parameter grid or the set of parameters you are interested in. Here we are first adding a grid that we want hashing term frequency number of features should be tested on 10, 100 and 1000, and logistic regression has a regularization parameter in it. It should be tested on 0.1 and 0.01. Then we hand over it to the cross validator, which is a Spark ML feature library. We hand over the estimator, that is the pipeline in this case. So, and the estimator parameter maps you have already created here, the parameter grid, and evaluator. You know that this class has only 2 classes, so you can use the binary classification evaluator, and in this case you are using two-fold cross validation. Yeah. And after that you call the, I am not sure, at the bottom of the line crossval dot fit, and you hand over the training data. So, training data must have been initialized before, that has been skipped. Now, how we can do the text stream classification by using the Apache Spark. Throughout the examples we have seen, we get the data at once, we process the data, do our model building and classify it. So, we split the data into test and training and do all those things at once and then stop the process. But for streaming, you will expect that you will have new instances at some point of time coming through. So, you have to classify those in new incoming instances. So, the problem in this setting, also in the hands-on section, is that we will have articles coming through the Kafka streaming process, and we need to classify which section they belongs. I think there are 4 classes for your example related to politics, business, social, and media maybe, these 4 classes. So for that, our target is to build a offline model based on the historical data. So what you will see, you will have we collected the data for 40 days using the API and train our model and saved it for later use. So this is the source code where you will be finding this offline method, offline model creation. Again, after doing the necessary imports, you create the Spark context. You will also create an SQL context to read the data from a given file. So your train CSV has the articles that you will be using for the train. It has 2 columns. First column indicates section, the last column indicates the content. And whenever you read with the SQL context, the name of the column they gave is _C0 and _C1. So in this case, you are just renaming the column names, and you should be able to see the top 5 of the records here. You do a training test split, and then you focus on pipeline building. So pipeline building includes the data preprocessing and the classifier itself. So here you are tokenizing the content, because you have an entire article, you have to divide it into words. So at this step, you are basically focusing on that task. You are given the content and you are splitting it into words. Then you remove the stop words, and then you run the term frequency calculation on the words that has been filtered. Then you run the inverse document frequency on the given term frequency calculation. And this is another part where you have an input column category and you convert it to label. You remember, we have to have features and label for the classifier to work in a pipeline. And you create the naive Bayes classifier, and you know this is a multinomial classifier because there are more than 2 classes. And you build the pipeline. You have several stages defined. First one is regular expression tokenizer, then is stop words remover, then you calculate the hashing term frequency, then you do the inverse document frequency. Then this is kind of a independent stage where you convert the category to label, and at the end you run the classifier. So after this step, the classifier should have features and label that we will see. Inside the regex tokenizer, you should be able to see that input column is content. It is coming from here, content to content match, and it gives output column name words. And you will find that the next stage, the input column is words, and you should be able to find out the mapping of this. Like after one stage, your output column becomes the input column for the next stage. So you have to specify the pipeline in this way, otherwise your source code will not work properly. And at the end, we call the pipeline.fit on the training data, where that has been found here on the training data, and you can save it for later use. So it has been saved in a folder named preprocessed fitted pipeline saved, where you can and at later point of time you can load the model, and without doing all these steps you can use that model to classify new documents or the existing documents you have. So as you go through, there should be pointers what line it does every. Again, to have the Spark streaming working, you have to run the Apache Kafka and Zookeeper server to handle the producer-consumer situation. And basically this one becomes your consumer. So the earlier example we saw, we just built an offline model and stored it. In this example, we will be seeing how we can use that model to classify new incoming documents we are getting through the streaming, Spark streaming. So you create an Spark context here. So this is your starting portion of the code. You create a Spark context. You give it a app name, is customary. Spark. Then you create the streaming context with 1 second of delay. And you load the model. Remember, we saved the model in a pre-processed fitted pipeline.saved folder. We load the model now. And we also have the some arguments on topics and the Zookeeper address. And we create a stream with Kafka utils. We specify the Spark streaming context and the topic, and also the Zookeeper address. Then we can do the we apply the map method, where the message is split into different parts, and we'll show how these parts work actually. So I have to do some writing on that part. So in this example, you are expecting new messages from Kafka. So how the messages from Kafka is organized? It is organized as follows: 0, double bar, business, assume this thing. So your message should look like this. There will be no new lines actually, but to make it see. So first one is your identifier for particular section. In this case, 0 identifies business section and the content of the article. These are your separators. Now, if you consider this line, you should be able to see we are splitting that based on that separator and creating 3 individual attributes. So after we call line.map on this instance, it should be look like the output of the line.map should be look like this. And Apple. So there are 3. Basically, just a little bit pre-processing on the data. So we create document tuple. So we call them a document tuple. This one is a document tuple. And we call the process method on each of them. So for each in the RDD, call the process method. So what process method does, it takes the time in the RDD. If the RDD is not empty, it will create a data frame with RDD on category and content. Oh, sorry. and just pardon me, I did some, this part is not there. So, there is only 2, 0 followed by the content of the article. There is one small. So, basically after splitting you will get 3, you will get 2 entities. So, 0 is the identifier for business class and the content. Yeah, this is the category, 0 is the category. So, when you have the RDD, you can expect 2 columns, that is category and the content. You call the model.transform on the data frame, and prediction show will show you the category estimated by the model or the classifier. So, that will conclude this session, and for reference you can go to these websites. I mean, if you have any question, let us know, I will try to explain more. So, that is the basically a complete outline what you will be doing in the hands-on section. So, hands-on section you will be doing, you will be collecting data, you will be building an offline model, then you will set up a producer that will produce the article and pass it through Kafka. Then on the consumer side you will load the model and do the classification on the produced messages, and you will also do the visualization with Elasticsearch and Kibana to see real time effect on the data.